So my name's Kyle Thompson. I'm a senior engineer on the AWS IDEs team. And joining me is...
I'm Deval Parikh. I'm a senior solutions architect based out of Los Angeles. I work with a lot of enterprise customers and very, very happy to be here today. All right, so let's dive into what we're going to just cover today. Just a quick glance at the agenda. We'll be talking about AWS developer tools at a very high level. I'll be talking about how to automatically provision your developer environments and provision any kind of software that you need to install on those in an automated self-service mechanism. We'll look into IDE tooling. Kyle will be doing and running some demos today, and then we will be also talking in depth on AWS SDKs and CLIs, just a whirlwind tour of everything AWS DevOps tools. All right, so let's talk a little bit, but before I get into this slide here, I want to just get a pulse in the room. How many of you guys are developers out here? Just want to see some, wow, cool. And any managers, execs in this room? Cool. We got quite a few hands here too. So let's talk about some of the needs of a typical developer, right? Developers want to develop applications as fast as they can. But they also need the right tool set for writing and editing code. They want a tool set to support debugging and any kind of testing in an intuitive and interactive manner. Leverage software development kits and CLIs to interface with AWS services. And they want CI/CD pipelines to release code faster in production with quality assurance, of course, and we'll be talking about that later in some of the slides. But developers are also looking at cross-platform support for their full stack application without having to really rewrite their code. And then one thing that I'm also observing as I talk and interface with many customers, part of my role here at AWS is that they also want to make use of tools with machine learning capabilities, right, to improve delivery of non-functional requirements like code quality, observability, things of that nature. So let's see how AWS helps achieve all of this. Let's take a look at that complete developer tooling landscape. Okay? So this slide here shows a comprehensive set of developer tools provided by AWS. Kyle and I have sat down and broken it down into categories to make it easier to understand how each tool can be applied in an SDLC. And then as we progress through this session, we'll make an effort to dive into each of these categories, explain a few tools in detail. But note that this is not an attempt to provide an all-comprehensive list of everything that's out there in AWS today. It's just, an effort to show you something that we think are valuable for developers today. Let's talk about that, but I want to just go back and reflect on the fact that for any one of you guys to develop on AWS, you will need AWS accounts, you will need tools and services especially, maybe S3, maybe EC2 instances, maybe some of the other services in order to interact from your IDEs or your laptops or wherever you are developing from, right? So let's talk a little bit about how to automate the provisioning of these environments, accounts, and some of the baseline tools that you may need to just get going. All right, so I just want you to take a quick moment and imagine that you are a very fast-growing organization. You're moving quickly to the cloud. You're tasked with setting up developer and other system user accounts while ensuring there is governance and cost averance. All organizations have policies, especially security is of prime importance, especially as you guys move your workloads into the cloud. And for those of you who have done this, you know it's a non-trivial task. You have to ensure there is security of approved installation of software in these accounts. You have to provision for this software, ensure it is patched and updated over time in developers' environments. And then, as you grow as an organization, you're looking at managing hundreds of these accounts and create processes to ensure governance over all of this, right? So welcome to AWS Service Catalog. So what Service Catalog does is allows you to create, share, organize, and govern approved software and AWS services through a self-service mechanism via a central repository. It allows you to standardize your infrastructure deployments, emphasize on homogeneous environment, important as you grow, for operational maintenance, ease, and support across your organization. And then AWS Service Catalog also enables you to add new versions of these software as necessary as you go over time. What else? Oh, yes, you can also control the use of IT services by specifying constraints. For example, it will make sure that you're not spinning up unneeded resources in some regions that you don't want the developers to be working in, or possibly restrict IP ranges for developers to be able to test or do whatever they need to be doing. And then what else can it do? I've been a part of AT&T prior to moving to AWS, and I've seen how Service Catalog can actually integrate really well into your ITSM systems. It could be ServiceNow, it could be Jira, it could be any of your tools from an automation perspective to enable this end-to-end, complete end-to-end automation from the time you create a ticket to the time a provisioned developer environment is created. And this all happens in a matter of minutes, not days where you have to wait and kind of just have your infrastructure guys come and get you those accounts created and provision things. Right? So a lot of good things in that terms. Automation is the key here, as you guys know, a lot of this. So just a quick reference architecture to show you how to provision this. So there's two things that you're looking over here in this diagram. But first, obviously, from a developer standpoint and managing all these accounts, you've got teams. You've got big data analysts. You've got data scientists. You've got your app dev folks. You've got DBAs that need resources, or some database developers that need resources spun up. So there's a lot of, hey, I need this, I need that. And you have to make sure that whatever is provisioned in those AWS accounts are approved by your organization. So you have to build those infrastructure as code, maybe Terraform templates, maybe you're using CDK or CloudFormation, whatever you're using, to create that stack of templates. But that's not enough, right? You need a mechanism by which, hey, I got a ticket in here. I need to spin up a developer account with a baseline set of tooling that is approved for the organization, and then allow developers to actually go in and get more of the products and services that they need in order to do project-specific or team-specific or business-specific development. So just a reference architecture here. What I'm trying to show is, you use an account vending Lambda function that will actually create your account. It will create an organizational unit if you're using AWS organizations. It will create that. It will make the new account available under that new OU. And then once that's done, it takes care of all the roles and permissions needed in order for Service Catalog to start provisioning not only just that baseline set of tools, but also tools that developers may need downstream, maybe an RDS instance, or maybe a SageMaker notebook, Jupyter notebook, or whatever it may be. So really, really powerful functionality, especially when you put it into a solutioning reference architecture like this, so that you can provision, set it up, onboard your developers, get them things going, run fast with whatever you need to do in order to make a difference, right? All right, so I'm going to hand it over to Kyle on IDE tooling. Lots of demos here, so very excited.
Live demos. We'll see how we go. Who here uses an IDE for the development? Okay, cool. Who here uses something from JetBrains, like IntelliJ, PyCharm? Who here uses VS Code? Visual Studio? Okay, cool. Cloud9, AWS Cloud9? Okay, cool. So what I'm going to talk about for the next few minutes is the offerings that we have for AWS in terms of IDE tooling. I guess I've got one more question. Who here has heard of the AWS toolkit? Okay, cool. So what we're looking at here in terms of this landscape diagram here is on the right-hand side? Left-hand, yeah, right-hand side in the IDE space. At AWS, we vend toolkits or extensions or plugins, depending on what IDE you're using. They call it different things, for integrating the IDE with AWS. And we call these the AWS toolkits. And the reason I asked that list of IDEs is because that's the IDEs that we support in the IDE toolkit. So we vend toolkits for 4 different IDE families. Obviously, AWS Cloud 9, our web-based IDE. For those of you who haven't seen it, who want a browser-based IDE experience without having to have anything on your laptop, definitely check out Cloud 9. We vend plugins for an extension for VS Code, JetBrains, suite of products, so IntelliJ, PyCharm, WebStorm, et cetera, and Visual Studio. So we're going to cover some of the features that exist in the toolkits, but rather than kind of do it as a list of bullet points, I think it's more fun to actually show you. So I'm going to switch across to my laptop now. Hopefully we can see this. Okay, so we can see this here. I'll pump it up I'll pump up the font if we need to. What we've got here is PyCharm Community Edition. I just picked one of our IDE families. And what I have installed here is the AWS Toolkit. It's just a plugin that's installed from the plugin marketplace. And with that, we have a number of options for integrating with AWS that I'm going to take you through. So the first one is I'm going to create a new project. And with the AWS Toolkit installed, I get this new project type when I kind of start that wizard. So what we're going to do is we're going to create a new Python-based serverless application. I'm going to give it a name here, and I'm going to hit create. Now, under the hood, what this is going to do is it's going to use a tool called the SAM CLI that we're going to learn about a little later in the presentation to bootstrap a project that kind of follows best practices with AWS, and it's focused on Lambda and serverless development services. So what we get here is a project structure. We have a template.yaml, which is our CloudFormation template that defines the resources that we're going to use in infrastructure as code. In this case, we have a single Lambda function. And the code that drives that function is in the app.py. How's the font size for everyone? Can we see this? Yeah? OK, cool. Shout out if this is too small. We're not going to dive too much into the code, so hopefully it won't matter too much, but let me know if you can't see. So the first thing I'm going to do here is I'm going to deploy this application or sync this application to my developer account that was provisioned through Service Catalog. So to do that, I need to connect the toolkit to my AWS account. Now, the toolkit, the main kind of entry point for the toolkit, regardless of whether you're using a JetBrains toolkit or a Visual Studio toolkit, is what we call the AWS Explorer. Varies a little bit depending on IDE, but usually it's on the left-hand side under a pane called AWS Toolkit. Up the top here, we have a drop-down, which is the credentials that have been loaded from my local credential file. So I'm going to select the demo profile. Now, this is an SSO profile. Who uses SSO credentials? OK, cool. So the toolkit is integrated with SSO. And so it'll automatically kick me out to the SSO login screen to take me through this so that I can authenticate. And hopefully I remember my password. I didn't. Third time's the charm. OK. So this is it's then going to ask me to auth the toolkit. I hit allow here. And I come back to the toolkit. And I see now I get a list of services there in the Explorer. So I'm going to, now that I've connected the toolkit, I'm going to actually deploy my application. So I'm going to right-click on the template. I'm going to come down to Sync Serverless Application. And now I need to fill in some details. So I'm going to give my stack a name. And the only other thing I really need to do here is to create an S3 bucket to put the artifacts into. So we're going to build the Lambda function, which then gets uploaded to S3. So I'm just going to put some We need to make sure these are globally unique. Okay, so I've got an S3 bucket created. And the other thing I'm going to do is I'm going to opt to build my function inside a container. So that way I don't need to worry about what software I have installed on my local machine. This works through Docker, and it will resolve a container that maps to the Lambda Python, in this case, runtime environment, and will build that function locally. So this is going to build and deploy a CloudFormation stack. And we can see here that it started to provision CloudFormation resources. Now, if I expand out, if I refresh the Explorer, expand out the CloudFormation node here, you'll see my stack creation is in progress. I'm going to double-click on that node, and that's going to load the CloudFormation stack viewer. And this is going to monitor my CloudFormation deployment as it happens, and we'll see as the resources get provisioned, they'll show up in green, and we can kind of monitor this progress. So I'm going to let this run, and in the meantime, we're going to update our Lambda function a little bit. So right now, the base kind of hello world function pretty much just prints out hello world, or returns hello world from the Lambda. I want to make it a little bit more interesting. So the first thing I'm going to do is print the event out so that we see it in the logs. And then I'm going to assume that the event is a person's name. So what I'm going to do is I'm going to change this response message here to be the event. So we're going to include the event. And while I was doing that, a little green box popped up there to tell me that the CloudFormation template was deployed. And we'll come back to that in just a sec. So before I sync this back to my AWS account, I want to test it locally. So I'm going to go up here to the run configuration that gets automatically created by the toolkit, and I'm going to hit debug. And that's going to prompt me to specify an input that I want to send into the Lambda function. So we said before that the event we were expecting was someone's name. I'm going to use my name, and I'm going to hit debug here. Then I'm going to set a breakpoint in my IDE. And what's going to happen here is the SAM CLI is going to build that function again. It's going to spin it up in a Docker container that's running on my local machine. And then it's going to expose a debug port, and the toolkit is going to attach to it. So what we have here is a Lambda-like container with Lambda context attached as kind of a full fidelity debugger. So at this point, I can kind of do anything that I would be able to do in a regular debugger. I can inspect variables. I can step over lines. Hopefully, you've seen kind of the debugging experience before. But this is debugging against something that is very, very similar to the Lambda runtime environment that's managed by the toolkit. So I'm happy with that. So I'm going to hit play, just play that out. And now what we're going to do is sync this back to the account, because I made my update and I want to deploy this out to the cloud. Now, to do this, I could do a full sync, which is going to build and deploy the CloudFormation template again. But I want to skip some of the CloudFormation steps, because I know all I've changed here is the Lambda function code. So inside the toolkit, I'm going to enable an experimental feature. So for those who didn't see, I clicked on the cog here in the toolkit. I'm going to go down to experimental features. Oh, and it's already on. So sync serverless application code only. So now when I right-click on the template, I get this code only option. It's going to load up the parameters that I had before. And when I hit sync, this time, instead of doing a full stack deployment, it's just going to bundle the Lambda for me, push that up, and tell the Lambda console to refresh the zip file. So the deployment will be much, much faster, because we're not going through the whole CloudFormation stack provisioning process. So that's completed now. And if I expand out my Lambda node, I know these things are getting a bit crowded. Sorry about that. We've got limited resolution. So if I right-click on the Lambda node and hit run, this is the remote Lambda. This is actually deployed to my account. I'm going to put my name in again, hit run, and we'll see here that I actually have the updated code there. There's a number of other services available on the left-hand side here. This is kind of the entry point, like I said. I'm going to list off a whole bullet point bunch of these in just a few minutes. So that's kind of a whirlwind tour introduction to the JetBrains toolkit. Very, very similar functionality available in our other toolkits as well. So what did we see there? We saw connection to AWS managed by the toolkit through SSO. We saw, jumping ahead here, new project creation. Saw CloudFormation syncing, and then that fast code sync. And we saw the Resource Explorer, that tree of resources that have integrations in the toolkit, in the IDE. So the next feature of our IDE suite that I want to talk about a little bit is Amazon Code Whisperer. So this was launched as a public preview on Sunday. And it is a machine learning powered code completion companion. It helps you to follow AWS and general best practices using machine learning to kind of detect and predict what you are trying to do and help make suggestions for you. Currently, it is integrated into AWS Cloud 9, VS Code, and the JetBrains suite of products again, and supports Python, Java, and JavaScript, and there are more languages on the way. That's the QR code for it. Like I say, it's currently in preview. So if you install one of the latest versions of the AWS Toolkit in any of these IDEs, you'll see that option. So once again, talking about it is one thing. I think it's much cooler to actually see it. So this time I've got a pre-recorded demo that we're going to kind of play here. So again, we're in PyCharm Community Edition. I'm going to enable Code Whisperer on the left-hand side here, go across into my code window, and start defining a function. So I'm going to give my function a name. And that's all Code Whisperer needs. It's going to automatically go off and figure out what we're trying to determine what we're trying to do and make suggestions for us, which we can then tab through. And when we find the one that we think is the closest match to what we're trying to achieve, we hit tab to insert it. And now we have, in a few seconds and a few keystrokes of a method name, we have 16 lines of code that achieves, hopefully, what we're trying to achieve, and does it with best practices built in. So that's Amazon Code Whisperer. But there's a whole bunch of other features in the toolkits, and I'm just going to quickly run through those in the interest of time. We said we wouldn't go too deep, so I'm just going to kind of do a bullet point list here. We have S3 connectivity in all of our IDEs that we support, so the ability to open S3 buckets and browse them like a file system, open them, upload, drag and drop, etc. In our VS Code and Cloud9 IDEs, we have the ability to visualize step function graphs. So this, for those who use step function state machines, you have the ability to visualize the graph of the state machine. I don't know why I picked such a simple state machine, but it works with more complex state machines as well. In our Visual Studio toolkit, this year we released a tool that allows you to actually migrate existing .NET applications onto AWS. So for those of you who are .NET developers and have existing, maybe non-AWS .NET applications, this tool will actually apply heuristics to the project and determine what is the best AWS compute target for that project type and make recommendations and then walk you through deploying that. Again, following best practices, you get infrastructure as code out of it and all that good stuff. It's really cool. We have a DynamoDB table viewer inside the JetBrains toolkit that allows you to view DynamoDB tables. In JetBrains VS Code, we integrate with App Runner, so you can create App Runner services and view log files and integrate with the App Runner service. Obviously, logs is a pretty core part of any developer experience, so we integrate with CloudWatch logs in all of our IDEs, including the ability to run QuickSight queries so that you can kind of do complex investigation of logs. We talked a little bit about the resource viewer. At the very bottom of the Explorer tree, there was a resources node. What this allows you to do is actually select from hundreds of different resource types to actually integrate with and view and list and describe inside the IDE. So that's the very bottom of the Explorer. And then we have step 3 debugging that we kind of just saw the demo of, so there's no screenshot for that one. And then the final feature that I'm going to mention, it's not the final feature in the toolkit, but the final one I'm going to mention, because I think it's pretty cool, is ARM Anywhere inside the JetBrains toolkit. So what this does is it will recognize any string that looks like an ARM, and this might be in a code file, it might be in a terminal output, and it turns it into a clickable URL. And when you click that, it will actually federate you into the AWS console to that resources detail page. So we have logic that determines where in the console to put you for that particular resource type. That's a super cool feature. So there we go. We've kind of done a very, very quick overview of the AWS toolkits. For those of you who use an IDE and work with AWS, definitely recommend you check it out. I'm going to pass it back to Deval now to take us through the AWS SDKs.
Thanks, Kyle. Can you guys just still hear me? How's this? Better? Yeah. OK, great. Wow, that was quite a tour. I loved everything that Kyle showed. I think if you can leverage only 50% of this type of tooling, you can go faster than what you're doing today, for sure. Hoping you guys agree. But let's jump into AWS SDKs. We want to just take you through a tour of what SDKs look like in AWS, the tool set that's available out there. And again, we've just created that classification of what is out there from an SDK standpoint. So again, it's a very primitive definition, but SDKs, at least from an AWS tooling standpoint, they work with AWS services natively through code in your editor. So you don't have to really get on the console. You don't have to connect anywhere. You could basically just use your IDE tooling, the way Kyle described, to execute your development projects. All right, so high level, SDKs are libraries for building on AWS. They're available in a variety of different programming languages. I'm just amazed at how we kind of keep bringing more and more SDK toolkit to the suite of AWS tooling here. They're all open source, so certainly available for downloads. And then AWS tries to create a consistent feature set across these SDK libraries, so it's not, hey, I'm only used to working on the JavaScript SDK versus I don't know how to deal with the Python SDK, for example. So what I have done is further broken it down into kind of classifications where it's mostly project-specific or team-specific or whatever development environment that you're working in, possibly a back-end application, possibly a front-end. So again, we've got the SDK language support, Java, Python, I talked about that. We're going to talk about Rust in a little bit. How many of you guys have heard about Rust or programming in Rust right now? Programming? Developing? OK, but Rust, that's the new scripting language. Folks are really, really optimizing how they're running code today. We'll talk about that in a minute, but then again, there is a suite of SDKs that will support your front-end, web, mobile development type environments. And then there is also very much service-specific SDKs that are available out there. For example, Amazon Chime SDK that can integrate with your JavaScript or your Android projects that you're working on. And then there's, with IoT technology taking up the front stage today, AWS has gone in and made available a suite of IoT device SDKs. Embedded C, Arduino, Python, C++, whatever projects you're working on. So I wanted to just step through a quick request lifecycle in the SDK process. How does the SDK client actually go, use your calling functions, objects, and then transform it over, talk to the AWS services and back, so you don't have to worry about all that. So just quickly, whatever you're developing today, when a caller passes an object or a request object, in other words, maybe a JavaScript object to the SDK client, the client takes it and actually serializes it to a wire format. The AWS services in the backend in the cloud, most of them, in fact, I want to say all of them use API. So you really are going to look into sending out an API request to an AWS service that you need to work with. It may be an S3 service. It could be an EC2 service, whatever that is. And then when a response is created, obviously it is created in JSON or an XML format. It receives bytes back from the service in the cloud, and then translates it back into a deserialization and deserializes it into an object. and sends it back to the caller. So this is just a quick response request lifecycle. You don't have to worry about this marshalling and unmarshalling of the objects. You're just really sending out your objects. SDK takes care of it. It understands because you're possibly developing in JavaScript. You're possibly developing in Java or Python, and those objects all are different in different formats as well, and the client understands that. All right, so we talked about Rust. For anyone who has not heard about Rust, and I saw quite a few hands, so I'll take that, but Rust is a statically typed programming language designed for performance and safety. It's a blazing fast and memory optimized or memory efficient language that is widely used today. It is used as an alternative to other systems programming languages like C or C++. And then we're really excited to announce the AWS SDK for Rust, which is in developer preview now. So if you haven't really tried it, go out and try, download the SDK, run it on your local, run it in a Lambda function, whatever works for you guys. And then, again, if you're coding in Rust already, and I saw some hands here, the AWS SDK for Rust simplifies the use of these services by providing a set of libraries. These are consistent across the board, just as I said, and they're very much familiar to Rust developers, and we'll take a quick look at an example. But it also uses modern Rust language and other modern language features like sync await, non-blocking I/O, and builders. And then the SDK integrates with popular libraries in the Rust ecosystem. You can use the Tokyo runtime, you could use tracing, you could use Hyper, whatever is out there that you are most familiar with or used to. One of the things that is also important to note is that AWS SDK, whether we're talking Rust or other programming languages, has a modular architecture. And so what it means is each of the SDK toolkit comes with a separate package. And in case of Rust, it's a separate crate, for example, for each of the services that you're going to use. And then why? Because, again, you don't want to download every other crate that you're not going to be using for 300 plus services or whatever the number of services that we have been putting it out there. It reduces your compile time, it reduces your binary sizes, and you're only dealing with what you really need to be dealing with in terms of the packages. Okay. And then these are all available on crate.io, so if you're interested, go ahead and download. I'm just going to show a quick example on how to use a Rust request to read all the items from an AWS DynamoDB. Anyone does not know what a DynamoDB is? Cool, wow, that's very, very interesting. So I'll skip that introduction part. But in this example, you'll see how quickly you can access any of the DynamoDB table with AWS Rust SDK and read items stored in that table. Before you start, obviously, whenever you're working with AWS services, you want to have an access key and a secret, use that credentials and store it in a credentials file. And then you would want to go out and actually download your AWS config crate and your AWS SDK DynamoDB crate to start working on the project. These are included in a file called cargo.toml. It's just a package file. It talks about what dependencies are needed to run a particular project. And then we are using Tokyo runtime in this case. So it's just pretty simple to set up the cargo.toml, and then making a request is even more simpler. You use the config SDK to retrieve your stored credentials that has permissions for you to read DynamoDB tables. So certainly make sure that your credentials have those roles and permissions. Create a client that can operate on your DynamoDB table using the AWS DynamoDB SDK. And then with these credentials, invoke the library's scan function. Once you have a response object, you can loop through it and do whatever you need to do with all the items in the table. So pretty simple snippet here, but it's pretty powerful in the way that it will run a
And
request.
all of our other SDKs for different languages basically follow the same pattern, right? So you create a client, that client exposes operations that allow you to interact with AWS.
Absolutely. Any of the services, just similar snippet. Okay, all right. So let's recap. You saw through that example snippet, SDKs take the complexity and the coding, just as Kyle said, so you can focus on coding and your business outcome, and you're not thinking about how to translate objects, how to talk to the services back and forth. Modular design, important so that you can minimize those compile times and binary sizes. And then all AWS SDKs support API lifecycle considerations such as credential management, retries, any kind of secure data marshaling and unmarshaling or serialization in that process, right? So I'm going to get back to Kyle. We have some more demos on SDK and some more advanced features.
Thank you. Yeah, so in addition to the kind of base service APIs that the SDKs vend, which matches the service's kind of API surface area, a number of the SDKs also provide some advanced features that we call higher level libraries that sit on top of those. And I'm going to take you through a couple of those today. Who's used any of the kind of higher level libraries? Okay, cool. Oh, a few hands, awesome. Okay, so the first one I'm going to take you through is pagination. So I'm going to skim a little bit the kind of definition of pagination. Hopefully, most folks are familiar with this, but historically, if we wanted to grab a bunch of data, we'd probably make a single call and pull it all over the network. But obviously, in the internet world, that doesn't really work. If we have a problem with the network or there's a blip somewhere, then we lose that whole chunk of data. So a pattern that we see everywhere on the internet, and AWS is no different, is chunking large data sets up into pages. And so in this example here, we've got a log stream that has a bunch of log events. The AWS APIs are structured in a way that allow us to paginate that. So we get a page, it gives us, with the response, it gives us some objects and a token to get the next page. We go out and make that subsequent call from the client to get the next page, and so on and so forth until we get all of the data. Now, what does that look like in an actual base SDK? So we're switching languages here to TypeScript. Hopefully that's hopefully folks at least have some familiarity with TypeScript. I know it's pretty popular. And here we have our client, like I mentioned before, this same pattern. And we're calling the getLogEvents API on it and passing some parameters. So we get that response, and then for each event in the response, we're just going to print the message out to a log file. But with pagination, we can't stop there if we want all of the log events. We need to check if there's another page. In this case, the token that determines that is the next forward token on the response. And then we make a subsequent request and do our print again. And we do this in a while loop until next forward token is null. So that's kind of the longhand way of doing it. With the SDKs, there is a simpler way, and that is using our pagination logic. So we generate paginators for paginated APIs based on metadata in those APIs. In the TypeScript SDK, you would import the paginate get log file or log events operation, and then it looks fairly similar. So we're passing a client, we're passing our parameters, but this time we get a paginator object back, which we can iterate over natively in TypeScript or JavaScript. So here we don't need to worry about shuffling tokens from the response to a subsequent request and doing while loops and stuff like that. We can just do a regular for loop on top of our paginator. And that's much simpler. So this functionality is available in a number of different SDKs that AWS vends, and obviously the patterns will be slightly different depending on the language, but kind of similar functionality there, helping you to paginate over large data sets. So the other pattern I want to take you through, which is again pretty common at AWS, is for long-running operations. And in the SDKs we call these waiters. So these are things that help you deal with that. So what do I mean by a long-running operation? We saw before when we did the IDE demo that we deployed a stack to CloudFormation, and it took a minute or so while those resources got provisioned. Again, we could just model this as a single operation where the client makes a call, it waits, the CloudFormation service goes through its state machine of vending, of provisioning resources, and then when it's complete, it finally returns to the client. Obviously, this is somewhat problematic because, again, if the network is interrupted, we have no idea how to understand that status. And from a client perspective, it's kind of a black box. We don't really know what's going on inside there. So instead, we break this up into two operations. We call create stack, and create stack is going to return almost immediately with a stack ID. And then CloudFormation is going to start doing its thing, provisioning resources. And as the client, if we want to know what's going on, we call describe stack and pass our stack ID. And we'll get back the status. And then we want to wait on the client until we've reached the status that we're expecting. So in this case, create complete. And when that completes, then we know that operation is completed. What does that look like in code? So I'm going to do this quickly, but again, it's the same sort of process here. We've got our create stack operation. We call describe stacks. We get into a while loop. We're waiting for that stack status to be complete. We're going to do some sort of a wait so that we don't pummel the service with requests and kind of burn the CPU on our client. And then we make a subsequent request. We'll look at the status again, and we'll kind of loop over this. And then when it's done, we're going to print saying that the stack was created. So looks reasonably simple, but it gets more complicated because a lot of these long-running operations have a state machine that has more than one terminal endpoint. What happens if we fail to provision one of the resources in CloudFormation? So now we need to know all of the terminal states in the state machine in order to make sure that this doesn't just spin forever. So, and then when that happens, we need to now deal with the fact that a failure may have occurred, and we need to kind of make another describe request to get the error message. You know, it gets complex fast. You need to understand that service's state machine. Thankfully, the waiters can help us with this process. And again, in the TypeScript SDK, this means importing a wait function. In this case, it's the wait until stack creation complete function. Nice long name. We're going to pass the parameters that we need, the stack ID in this case. And now we can just await. So this uses a standard JavaScript future. And we can just await on that using the kind of async IO. And when that completes, we will get stack created. In the background here, what's happening is we're polling the service. And we have logic to understand what are the terminal states and what are the success states. And then we'll respond when it terminates. Now, obviously, we also probably need to handle error handling here. But this is just a try-catch like any other. So there's you're not going to get stuck in an infinite loop here. So that's waiters, again, available in a number of different SDKs. We use each SDK uses the pattern that's specific to that language in terms of the await, async, whatever the, in the case of Java, it's futures, you know, whatever the language's async pattern is. But recommend you check that out if you use any long-running operations. So we're on the home stretch now in terms of the tooling that we're going to take you through. Devil's going to take us through some of the CLIs that are available.
Wow, that was fascinating to see the waiters go back and forth. You guys probably are, some of you are front-end developers, potentially understand promises as well. All right, let's switch the subject a little bit, talk about CLIs that are available for you to interact with AWS services in the cloud. So from a definition standpoint, obviously, CLI is your command line interface. It allows you to automate service management with scripts. We're going to actually try and see how we can not only describe stacks with application code, front-end code, but you could possibly do that through a CLI function as well. So just a real quick look at, you know, the list of CLIs that we've put together. This is not a comprehensive list of everything that's out there, just something that we thought is valuable for you guys to kind of take a look at. We'll be touching a few of these here through this series of slides. And so let's first talk about AWS CLI. How many of you guys do work with AWS CLI? Have it installed, downloaded? Yeah. Okay, great. Wonderful. So very simple, right? It's a unified tool to manage your services. AWS services, by the way, control multiple AWS services from the command line. Pretty powerful. EC2, Elastic Kubernetes service, container orchestrators, whatever you may have. And then it's obviously accessible by Linux or Windows. You could also remotely access it. There's a cool feature that Kyle's going to actually demo right after I'm done with my talk, and I'm going to keep it a surprise here. But you can install this on Windows or Linux, Mac, whatever machines you have through some of our provided bundles. So if you've not done that, check it out. Just a quick breakdown of what a CLI command looks like. It's just, parts of the CLI. Any AWS CLI starts with the word AWS. The next set is the actual service name. We're still talking cloud formation, so I thought I would just bring this in as an example, kind of just, related to how CLI will present you back with status. And then the second one is actual operation on that particular service. We're trying to see where we are with the cloud formation. Has all those services that I've set up with my infrastructure as code been created or not created? Where am I in the creation phase? So, and then, the last one is obviously your parameters. It's your stack name. Kyle created a stack earlier in the IDE tooling with the name myStack, similar thing here from a parameter. And then what you really get is, just as I said, any kind of interaction with AWS services in order to talk to them is an API call back to the cloud. It returns back an HTML, a JSON or an XML object. So the response object is pretty simple. This is a JSON object here that you're looking at. You may be interested in, when it started creating the services, but you may also be interested in something called the stack status in the middle of this particular JSON output, where it basically says whether your stack was completed, creation was completed or not. So, some of these things, as you move your application's development forward, right? Stack is created, now I need to do this. All right, Kyle's going to actually demo something called AWS Cloud Shell with exact same CLI parameters and structure that I was showing you. That's the surprise, so Kyle, take it on.
Who's heard of AWS Cloud Shell? All right, cool. So hopefully some folks will learn something new today. So AWS Cloud Shell was launched a few years ago now, and it is a CLI in the AWS console, effectively. So I'm in the AWS console here. What I'm going to do is click this terminal button, and what this is going to do is actually spin up a Fargate container for me and put me into it with an interactive shell. So installed into this container is the AWS CLI and a number of other kind of common developer tools. Now what we're going to do is we're going to do our CLI command again, our describe stacks, but this time we're going to use the CLI's auto prompt feature. So I'm going to do AWS CLI auto prompt and hit return. And what that's going to do is it's actually going to take me through the process of constructing a CLI request. So we know we want to talk to the CloudFormation service. So I see here I've got both the service name, and it's a little bit hard to read here, but you've got the description there as well. I'm going to hit enter, hit space, and again it tells me what operations are available on CloudFormation, kind of like you're in an IDE with autocomplete. Now we're going to describe stacks right at the bottom here. And again, it's going to prompt me to say these are the parameters that you're available to kind of send to that request. Now, in the case of a describe stack, we need a stack name. So I'm going to go stack name. And here's what I think is the coolest feature about auto prompt. When I hit space, it's actually going to list out the resources that match that parameter's type. Based on the list API. So it tells me I have my stack. I'm going to hit that and hit enter. And there is my AWS CLI command for describing stacks in Cloud Shell using the AWS CLI's auto prompt feature.
That's pretty cool in my mind. It just gives you more power over what you want to do, where you want to do, when you want to do on AWS. So thank you, Kyle, for that. All right, let's move on. We're going to talk a little bit about another CLI called AWS Copilot. And yep, right here. So this is another developer aid tool. and it allows you to deploy your full stack application on Amazon ECS. ECS is Amazon's native container orchestrator, AKA Elastic Container Service. Right? So AWS Copilot is an open source tool that developers can use to deploy containerized workloads to Amazon ECS. You can use it from the command line to build, push, and deploy application containers without having to touch the AWS Web Console. And that, in my mind, is a pretty powerful way of quickly deploying workloads that you just think you don't want to waste your time in figuring out what the configuration is going to look like, how to provision resources in the back end. From an infrastructure perspective, you just want that workload up and running in a matter of minutes. All right, so this is how it looks like from a build perspective. All it takes is a few commands to build the infrastructure for deployment. You initialize the container framework with the command copilot init. That's it. And that basically means all you need to bring with you is a Docker image or a Docker file and give it to Copilot and figure out how to deploy it on ECS. Right. You can also initialize storage if you need any kind of persistent storage associated with that particular workload. And then it will, in addition to that, it will provision your application's logs. And on top of that, with one more command, it will actually build observability mechanisms around your deployments. Now you have a full end-to-end working deployment that you can go check logs, make sure that it's working, get notifications if you need to set those things up through observability mechanisms, and move on to the next set of tasks. Right? So what's more, Copilot will provision your CI/CD pipelines with a single command. It will create a fully functional automated release pipeline that can connect to your Git repo and deploy a new version of your application whenever you push code to your repository. Pretty powerful. All right. And yeah. And operate, right? Once your containerized workload becomes operational, the infrastructure Copilot has built for you will allow you to view the health of your applications. You can tail your logs. You can even shell into your containers to investigate any processes that you may need to, and then change any kind of auto-scaling associated with your workload based on any kind of load or network traffic changes. In my mind, again, it's pretty powerful. I just want to give a quick example of a company called CA Advance. It's a Japan-based company. It was founded in Okinawa, Japan, and it provides services around internet media, including ads and games. They've reduced their operational load from managing time-consuming processes, such as configuration file changes, rolling out new updates to production workloads, and backing up files, all of that in a matter of hours and not days any longer with Copilot. So just a quick way to look at it. And then off to Kyle. He's going to talk about SAM CLI.
Thank you. So yeah, we had a little bit of a preview of the SAM CLI when we did the IDE demo, but I thought I'd kind of take you through it in a little bit more detail. No demos here this time, but I just want to kind of explain the magic behind the toolkit a little bit more. So SAM, for those who are uninitiated, is the serverless application model. And it's a set of abstractions on top of CloudFormation that effectively groups related services that are often used together into simpler to use and configure components. So the classic example is a Lambda function with an API gateway API in front of it. That's defined as a single resource in a CloudFormation template. And the serverless application model does the work of translating that thing into the actual CloudFormation resources that get provisioned. And in fact, the resource that we saw in the template file in the IDE demo was a SAM serverless function rather than an AWS Lambda function. So that kind of blew out into an API gateway API as well. SAM has a CLI associated with it, which is the thing that powered the step 3 debugging process that we saw in the IDE. But it also does a number of other things. So it does the sync process that we saw, including that kind of fast path code-only sync that we executed through the IDE. And the other cool feature that it has is the ability to watch. So if you run the watch command using the SAM CLI, it'll actually watch your workspace directory, and as you make changes, it will determine whether a code push needs to happen or whether if you've made an infrastructure change, if a CloudFormation deployment needs to happen, and it kicks off those processes in parallel in the background. And the beauty here is it kind of aids your developer workflow. So you're shortening the code deploy test cycle there because it's kind of taking away the heavy lifting of having to determine when a deploy needs to happen. So if you use Lambda, if you use API Gateway, if you use CloudFormation, I definitely recommend checking out the AWS SAM CLI. And as I say, it's the thing that also powers some parts of the AWS toolkits, the AWS IDE extensions. So that's it in terms of new content and tools that we're going to cover today. I'm going to do a quick summary. So we looked at the kind of overview, the landscape slide of all of the developer, well, not all of the developer tools, but a lot of the developer tools at AWS and their classifications. We looked at Service Catalog and how that can help you provision developer accounts at scale and securely. We looked at our IDE offerings in terms of the IDE toolkits, the extensions that we vend for various IDE families that help you interact with AWS. We did both kind of a high level and a slightly deeper dive into the SDKs and how they can help you develop against AWS services. And we looked at some AWS CLIs, including the AWS CLI, and we snuck a little demo of AWS Cloud Shell in there as well. So lots of content. Each of these topics really has probably its own session, either at reInvent this year or in previous years. So definitely check those out, or check out on YouTube if you want to dive deeper into any of these topics. But with that, I want to close. I'm going to thank everyone for being here. And Devil and I will be up on stage, or probably off the stage, actually, at the end if you had any questions. So thank you, everyone.